Now that you know a little bit about Arduino from my introductory tutorial, let's jump right into the good stuff. Today we'll be going over digital outputs and how to use them. The Arduino Uno has 14 pins, and they can be used each as a digital output. A digital output pin essentially does one of two things. Either turns on, formerly known as going high, or it turns off and goes low. It works with the basic high or low, on or off logic, binary 1 or binary 0. When a pin is set as high, the Arduino outputs 5 volts. When a pin is low, it is pulled to ground, or 0 volts if you really want to call it like that. So, let's build a circuit that makes use of digital outputs. Okay, we are now going to assemble our very first Arduino circuit. This is based on kind of the blink sketch. This is based on the blink sketch we did earlier. The only difference being we're not going to be using the integrated Arduino LED on pin 13, but we're going to be using our own LED. This little thing right here. This is a 1.8 volt red LED. It uses around 20 to 25 milliamperes of current. The LED has two legs, a longer leg, known as the anode, or the positive side, and a shorter leg, known as the cathode, or the ground. You can also see, inside the LED, you have two little piece components. The little component is the anode, or the positive, and the big anvil-like component is the cathode, which is going to be the ground. So, let's wire this up. First, we're going to take a look at our breadboard. Our breadboard is basically what we're going to be using to build our circuits. The breadboard has voltage rails going here from left to right for our 5 volt and our ground, and they are all connected, as in the positive is connected through this entire surface, the negative through the entire surface here. And then we have connections here. These go vertically from top to bottom, so basically everything here is a connection, everything here is a separate connection, and so on and so forth. Now between this divider line, these are separate connections. So we're going to start off by taking our Arduino and we're going to locate the pins we want to use. Like in our last sketch, we are going to use pin 13. Now, pin 13 is going to be our LED pin. So we're going to plug in a connector here, and we're also going to need a ground pin. Thankfully, we have a ground right next to pin 13. So we're going to plug in yet another pin right there. Now we're going to build our circuit. We're going to take note of the long end of the LED, the anode, the positive, and we're going to plug it in. So now we have the anode, or the positive, right here, and the cathode, the negative or ground, right here across this line. So you might think, well, wire up the red positive pin wire here and the ground right next to it, right? And you'd almost be right, except the Arduino will push 5 volts through our circuit, and this will most certainly fry our 1.8 volt LED. So what we're going to use is a 220 ohm resistor. Now I'm going to have a tutorial coming up talking about Ohm's law and how to choose resistors, and also how to read resistors based on the color codes on them. But for now, just note we're going to be using a 220 ohm current limiting resistor in series that we're going to place here into the positive side of our LED and into a separate channel on our breadboard. And now we're going to have our pin 13 go through the resistor. So basically the current's going to go through the resistor into the anode, or positive part of our LED, and then we're going to connect it up to ground. And our ground is going to be right here next to the shorter leg of the LED. Final circuit looks somewhat like this. You have pin 13 coming in right next to line 44, going through the 220 ohm resistor, which then goes directly, it's kind of hard to see, but it goes directly into the same rail as the anode or positive end of our LED. And then we have the short end of our LED, or the cathode, also known as the ground, going straight through our black wire into the ground pin right next to pin 13. So, now that we've wired this up, we're going to hook this up to our computer, upload the Blink code, which I will be providing on my website in the description below, and we're going to basically test this out. Today we're going to be blinking an LED. The Arduino, as I mentioned earlier, has a built-in LED on pin 13. So we're going to start by defining the LED pin and giving it a value. Now int is a data type, in this case an integer. We're going to be declaring a variable, basically declaring and initializing a variable. So we're going to declare the data type first, which is an integer, by writing int. Then we're going to give it a name. This can be anything. I'm going to call mine LED pin. And we're going to set its value equal to 13. Now when writing code, if you want to set something equal, like a variable equal to a value, use $=. If you want to check if something is equal, we use 2. But we'll get into that later. So we're going to create LED pin 13. We're going to also write down a comment by doing 2 forward slashes. And this is basically allowing us to leave ourselves a note or a comment on our code without it actually running in the code or in the program. So if you don't want to forget what a piece of code does, you comment it, and I highly suggest you do this. So here we're going to say create and define an integer variable LED pin and set its value to 13, which will be our LED pin. Now this is not necessary, as this is a very simple piece of code, but it's good practice on more complex pieces. Now in the void setup function, we're going to use the command pin mode to set the LED pin, which is 13. This basically will equal 13. We're going to set that LED pin as an output. And that is all we need to do. Now the Arduino knows that pin 13, called LED pin, will be an output. Now inside our loop, we're going to do a digital write, which will basically either send a high or low value, 5 volts or 0 volts, to our Arduino pin 13, to turn on and off whatever is on that pin, in this case the built-in LED. We're going to type in LED pin, and we're going to set the pin to high. So basically this Now, it is important that after each line of code you include a semicolon to let the program know that's the end of the line of code. Next we're going to set a delay because we want this to blink. This is in milliseconds, so 1000 milliseconds is a second, so wait for 1 second, 6000 milliseconds. And then we're going to do another digital write to change the state of the LED pin to low, turning it off. And then once again we're going to add a delay of 1000 seconds. So again we wait for 1 second. And that's it. Now if we compile this by hitting the check mark here, verify, we're going to want to save this. So let's save this as, say, blink, hello world. It now compiles. And here you see I made an error. Instead of putting a comma, I accidentally put a period. And that's good to always verify our code to make sure you have no errors. Now when it says it's done compiling, it means our code is error-free, and we can now hit upload to upload it to our Arduino. You notice since we're using the same pin as for the integrated LED, both LEDs are blinking. Now this is possible and safe as we are using a current limiting resistor. Had we not used this, this red LED would burn out, while the integrated LED has a built-in resistor of its own, so we don't have to worry about that. You should now be able to create simple circuits and utilize digital outputs on the Arduino. Go ahead and experiment with different LEDs and different delay values in our blink sketch to get more familiar with this concept. In the next video, I'll be covering digital inputs and how to add buttons to your project. That's all for today. There'll be a link down in the description below with a full written guide and the code files. If you've enjoyed this video, give it a thumbs up, comment, and subscribe if you haven't already. While you're at it, check out some of my other tutorial and project videos. See you next time.